everybody. We're going to review today the Chapter 1 test. I'm going over the items that will be covered on that test on Friday. So I wanted to walk you through this before you have to take the test. Starting on number 2, it says Nancy wrote the greatest number that can be made using each of the digits exactly once, which means you're going to have to use every single one of these digits to make that greatest number. So I started by drawing out my 6 blanks because obviously you have to have the entire 6-digit number written out down here. Now, in order to make the greatest number, you need to think about your placement of the digits and how that involves your place value. Now, obviously, in this chapter, we have learned that this is the ones place, the tens, the hundreds, the thousands, the 10,000s, and the 100,000s place. And the place that has the greatest value is the 100,000s place in our situation. So what you would do in order to make that greatest number, you would want to start out with the highest value digit and the highest value place value. So you want to put the 9 in the 100,000s position because that is the place with the greatest value. Then you want to go down from there. So you would follow it by the next highest number or the next highest digit, which would be the 8 in the 10,000s. Then the next highest digit that you could use would be the 5, and that would go in the thousands position. Then you would go down to the 4, then the 3, and then the 1. So your final answer would be 985,431. How do you know that's the greatest number? Well, because you put the greatest value digit in the highest value position, and you worked your way down from that until you got to the very lowest value position with the lowest value digit. So we're going to do the same thing on part B using the same exact numbers, only we're going to do the opposite of what we just did. Instead of the greatest number that we can make, we are going to actually make the least number that we can make. And once again, we have to use all of the number cards, or all of the digit cards, I should say. So we have another 6-digit number, but to make the least number, we need to start in the highest value position again, only we want to do the opposite of what we just did. So to make the least value number, we want to start with the highest place value with the lowest digit available. So that would be the 1. So then we would go to the next, and that would be the next to lowest number, which would be a 3. And the next position in the thousands would be the next lowest number, a 4. And then the next lowest position would be a 5. And the next lowest position would be an 8. And the next lowest position would be a 9 in the ones place. So you would end up with 134,589 as your answer. How do we know this is the least number that we can make using those same digit cards? Well, we started at the highest value position with the lowest value number, and we worked our way toward the right-hand side, which is the lowest value position with the highest value number or digit. We may have had a follow-up question here. And it says, explain why the value of 4 is greater than the value of 5. Well, we all know that 5 is always more than 4 if we're just working with a 5 and a 4, but not when it comes to place value. You have to look at their position in the number. The 4 is 1, 2, 3, 4 places over. So that means not ones, tens, hundreds, but thousands. So the 4 really is equal to 4,000. But the 5 is 1, 2, 3 places over, which is ones, tens, hundreds. So the 5 is actually equal to 500. And we're going to go on to the next page. And on the next next question, we have a U.S. mountain peaks chart. And they want us to categorize the mountain peaks into the box that describes its height in feet. So the mountain will either fit between 14,000 feet and 14,300 feet, or between 14,301 feet and 14,500 feet. So what I want you to notice about this table is that all of these mountains fall into the 14,000 feet category. And both of these boxes are dealing with 14,000 feet. So you can focus your time and effort into what's behind the thousands period. Focus on the hundreds and what that involves in order to categorize them where they go. So if we look at Blanca Peak, it has 14,345 feet as a height. So where would 345 feet go? Would it go between 0 up to 300 feet? Or would it go from 301 feet to 500 feet? Would it fall between those numbers? So we're looking at where it would go between, is 345 between 0 and 300? Or is it between 301 and 500? Blanca would fall between 301 and 500 because when we count from this number to this number, we would pass 345. So Blanca belongs on the right-hand side. The second number is Crestone at 14,294. So when you look at this number behind the thousands period, we have 294. And if we were looking as to where that would fall, when we count, we would count 294 in between 0 and 300. So Crestone would go on the left side. Humboldt Peak is 14,064. So we are really focusing on the 64. And I know that when I count between 0 and 300, I'm going to pass the 64. So I know Humboldt also belongs on the left side. On the right side, we have Mount Whitney, 494 feet above 14,000. So 494, ooh, I know that's close to 500. So I know that 494 is right before I get to 500, pretty close. So I know it's going to fall on the right-hand side. I look at University next, and it is 470. Well, I know my 400s all fall in between 300 and 500. So I know that University would fall on the right-hand side also. And the last is White Mountain, and it is 14,246. So if I focus on the 246, I know that 246 is before I get to 300. So I would put White Mountain on the left-hand side. Moving on, it says, circle the name of the tallest peak. Explain how you know which of the mountain peaks is the tallest. So if I go back up here, like I said before, they're all a little over 14,000 feet. So when I look at this back number, I am going to look for the largest number behind the thousands period that I can find. That will let me know which is the tallest mountain. So of all of these numbers, I have a 300, a 264, 494, 470. Those are the biggest so far, and a 246. When I look, I can tell 494 is bigger than 470. So I know this one is the tallest peak of all. So that would be Mount Whitney. How do I know it's the tallest? Because when I look at all of the heights on the table, that is the largest number. Now, going on, going to skip number 5. We're going to go to number 6. Bobby and Cheryl Bobby and Cheryl each rounded 745,829 to the nearest 10,000. Bobby wrote down 750,000 and Cheryl wrote down 740,000. And we want to know who's correct. And we need to find out what they did wrong. So we started with this number. What you need to be careful of is that what position you're rounding to. It says round to the nearest 10,000. So you have to know, where is that 10,000s position? Well, we know from this chapter we have ones, tens, hundreds, thousands, 10,000s, 100,000s. So when I did that, I realized 4 is in the 10,000s position. And they said they wanted us to round to that position. So in order to do that correctly, you have to look to the neighbor on the right, which happens to be a 5. And the rule in mathematics says that if this number that is the neighbor, if it is a 5 or larger, you round up. And if it is below a 5, a 4, a 3, a 2, or a 1, or a 0, you do not change the number. So the 7 in the 100,000s place stays the same. The 4 will actually go up because this is the magic number. If it's a 5 or bigger, we go up. And 1 up from 4 happens to be a 5. And this neighbor and all the other neighbors become zeros. And you've rounded to the nearest 10,000. Now, looking back, since Bobby chose 750,000, he is correct. So Bobby is correct. And we need to think about Cheryl and what she did wrong. If she rounded it to 740,000, I'm guessing she forgot that 5 means you round up, and I think she rounded down by mistake. Going on. Number 7. It says the total season attendance for a college team's home games rounded to the nearest 10,000 was 270,000. For numbers 7a and 7d, we are going to say yes or no if these numbers could be the exact attendance. So basically what they're asking you to do here is to round each one of these numbers to the nearest 10,000s place again, because that's where the number stops, so it's obviously rounding to the 10,000s. And we're going to see which of these round accurately to 270,000. So we're going to start with the first to the 10,000s place. I see a 6 in the 10,000s. I see a 5 next door. And I know the mathematical rule that if there's a 5, this is going to round up. So I leave the 2 alone. I round the 6 up a level to a 7. And the rest of the neighbors become zeros. So does it match up to the 270? Absolutely. So we mark yes. The next number. 260,987. We're going to round to the 10,000s place. There's a 6 there. We leave the 2 alone. Look at the neighbor to the 6. It's a 0. If it is not a 5 or larger, you leave it alone. So we're going to leave the 6 alone. Put zeros in for the neighbors, and we end up with 260,000, which does not match up, so it's a no. C. Rounding to the 10,000s place, which is the 7, we're going to leave the 2 alone. We look at the neighbor. It is a 4. Remember our rule. This has to be a 5 or larger to make the number in the 10,000s go up. Since it's not a 5 or larger, we're going to leave the 7 alone, and the rest of the neighbors become zeros. So, does that match up to 270,000? Yes. The bottom one, we have 206,636. The 10,000s place has a 0 in it. And if we look to the neighbor, it's a 6. So if we follow the rules correctly, 5 or larger, we go up. So the 0 goes up to a 1. The neighbors become zeros. And we end up with 210,000. Does that match up to 270,000? No. Moving on, we have another problem, and it deals with population, and it has a table to go along with it. And we're going to look at this table. We're going to ignore this side of the chart. It's a little confusing with all those numbers. So we're going to ignore that side. We're going to focus on the left-hand side. And it asks us on number 8, how many children are under 10 years old? Show your work. Well, this is where you have to use a little common sense. It says under 10 years old. That doesn't mean age 10 to 14 or 15 to 19. Under 10 is going to mean from 5 to 9 and also under 5, because all of these kids, no matter if they're 1-year-old, 2-year-old, up to 9 years old, they're still under 10 years old. So we have under 5 years old is going to be 35,010, and ages 5 to 9, 31,406. And so if we have that many kids that are under age 10, they want to know the total. How many total kids are under age 10? Well, the only way to find that out is to put these two things together. And to put it together to get a total, they're asking you to add. 6 plus 0, 6. 1 plus 0, 1. 0 plus 4, 4. 5 plus 1, 6. 3 plus 3, 6. So how many children? 66,416. Now, how many people are between ages of 20 and 49? We would do the same thing again. We would add those two sections together because we have a 20 to 34 group and a 35 to 49 group. So we would put those together like we did the children, but we're going to skip that and go to number 10. This is very interesting. Look at the word use here at the beginning. It says, how many more children? How many more children are under the age of 5 than between the age of 10 and 14? Show your work. So I know the underage 5 category, back up here on the chart, is 35,010. And I know the 10 to 14 category is 30,253. Now, you have to think about what they're asking you to do. It says, how many more children are under the age of 5 than between ages 10 to 14? So how many more children kind of means find the difference of kids between this age and this age. So to find a difference, we don't add. They're not asking us to find a total. They're asking us to find a difference. And with difference, you have to subtract. So we subtract by looking at our numbers here. We cannot take 3 from a 0. We have to borrow from the tens column. So we take a 10 away. That leaves us with no tens. And then we have a 10 now in the ones. So we bring the 1 over to make it a 10. So 10 take away 3 is 7. Now, once again, we cannot take 5 from a 0. So we have to borrow. The problem is the neighbor is also a 0. So you can't borrow from nothing. So what you have to do is when you borrow from the neighbor that's a 0, you have to look at the 0 along with the next number that does have something you can borrow from, which would be the 5. So when we are looking at this 5 and 0, we're thinking, that's 50 hundredths. So when we are borrowing to get a 10, we need to think of that as 50 hundredths, and 1 away from 50 is 49. And so we take that, and then we bring over a 10. We have 10 minus 5 now. We have 9 take away 2. 4 take away 0. And we end up with 4,757. And that has a label of children because that's what we're counting. And that's that. Next problem. We are looking at the value of digits. And like we said before, depending on what place value position that digit is in, will determine the value. So in this number, the 7, we're trying to find out what is the value of this 7. Now remember, we have ones, tens, hundreds, thousands, 10,000s, 100,000s. So if I look at this 7, I know it's in the 10,000s place. I could also write down that 7 right below where it is and put zeros in place of all the neighbors behind it, and I would know for sure that this is worth 70,000. Is that the same as 7,000? No, so it's false. What is the value of 5 in this number? Well, I know that 5 is in the 1s, 10s, 100s. I could also write the 5 right below where it is and put zeros behind those numbers where the neighbors are, and I would know it is 500, which would be true. To find the value of 2 in this number, there's the 2. So I would think 1s, 10s, 2 10s. 2 is in the 10s place. Or I could write it down right below itself, and I could put a 0 for the neighbor, and I would know that it is 2 10s is 20. So that does not match up to that 200 that they think. The next one is the value of 4. And if I look at where the 4 is positioned, we have 1s, 10s, 100s, 1000s, 10,000s. So I could double check myself by writing that 4 and putting 0 where all the neighbors are. And if I look, I see 40,000 is, yes, 40,000. So true. On the next problem, it says select another way to show 403,871. Now, when I said that just now out loud, the easiest way to read a number like this that's very large out loud is to break it into its periods. So that means you start with the largest period, and you would say this first, 403. And then when you see a comma, when there's just one comma, you're talking thousands. So it'd be 403,871. So when we say that, we're breaking it apart into its two parts, actually, 403,871. So when I said that out loud, I know I can write it in words, just like I said it. So 403,000, it looks like A, B, and C all have that. So we'll look at the second part, 871. 801, not correct. 71, no, they forgot the 800. 871, yes, that is correct. What about down here? This is called expanded form, and all they're doing here is breaking all of the place value numbers apart. Whatever number is in that place value, they're pulling it apart. They have the 4 in the 400,000s, which is correct. And this at the bottom says 400,000, so those are all correct so far. We have a 0 in the 10,000s. So there's nothing in the 10,000s. This one says 38,000. That would automatically be wrong because there isn't anything in the 10,000s position. This one skips and it goes to 3,000. Yes, that's what's next. We have the 400,000, then we have 3,000. So this one's correct and this, because this says 3,000s. Then we have 8 in the hundreds, so 800, 800. Then we have a 7 in the tens, which would be 70 or 7 tens. And then we have a 1 in the ones, which would be a 1 or 1, 1, whichever way you want to say it. So both of these are correct. Down at the bottom, we have a rounding problem again. And it says there were 13,501 visitors to a museum in June. What is that number rounded to the nearest 10,000s? So now here we go again, 10,000s place. Ones, tens, hundreds, thousands, 10,000s. So we're rounding to the 10,000s. We look at the neighbor next door to determine, does the 1 stay or does it go up to a 2? So when we look next door, we have a 3. The rule is if it's a 5 or larger, we round up. If it isn't, we leave it alone. So with the number 1, since it's not a 5 or bigger neighbor, we leave the 1 alone, and we're going to make all of these neighbors into zeros. So we ended up with 10,000. Next problem. New Mexico has an area of 121,298 square miles. California has an area of 155,779 square miles. How much greater is the area in square miles of California than the area of New Mexico? Show your work and be able to explain. Look at what they're asking us to do. Did they ask us how much total area New Mexico and California have together? No. They ask us how much greater is the area of California than the area of New Mexico. So we're finding, again, a difference. We're finding the difference in the land area that those two states have. So when you're finding a difference, you have to subtract. And we always put the bigger number on top, 155,779 minus 121,298. And we're going to subtract. 9 take away 8 is 1. We cannot take 9 from a 7, so we have to borrow from the hundreds. We're going to make it 6 hundreds, and we're going to bring a 10 over. So now, 17 minus 9 would be 8. 6 take away 2, 4. And now we have 5 take away 1, 4. 5 take away 2, 3. So the difference in area of square miles, 34,481. And moving on, we are matching the value of the 5 to the correct number. Now, what I would do if I were you, I would think about place value once again. And I would think, ooh, this 5 is in the thousands place. So if I have a 5 in the thousands place, that means 5,000. To double check myself, I could write it down, the 5 right below the 5, and I could put zeros here in the neighbor spots. And yes, I'm right, 5,000. This number, I have a 5 in the 10,000s place. So if I double check by putting zeros behind where the 5 is, I see it's 50,000. 5 10,000s is 50,000. With this one, I see I have a 5 in the hundreds place. And if I put zeros behind where the neighbors are right now, I would get 500. And this 5 is in the tens place, and I only have 1 0 behind it, so guess what? It's worth 50. Very back page. During September and October, a total of 150 visitors went to Grand Canyon National Park. The 448,925 visitors went to the park in September. How many went in October? Show your work. So once again, you're going to have to use common sense here, and you're going to have to think yourself through this. You're going to have to decide, do I add or do I subtract? In this case, they gave us a little hint. They told us the total visitors were 825,150, and that is for September and October put together. So that's the entire total for those 2 months. Then they went on to tell us that there were this many visitors in September by itself. So how are you going to find October by itself? If you know the total and you know one of the parts, then you just have to find the other part. So to find a part, after you already know a total, that's when you're going to subtract. So we're going to start with the total, 825,150. We're going to subtract the part that we know, 448,925, to find the missing part. So we obviously cannot take 5 from nothing. So we're going to borrow from the tens department. We're going to make that 5 a 4, bring 1 over, a 10 over. And so now we have 10 minus 5, 5. We have 4 minus 2, 2. Look at the hundreds place. You cannot take a 9 from a 1, so we must borrow from the thousands place and make that 5 a 4. Bring that 10 over. So we have 11 minus 9, 2. Then we have 4 minus 8, which we cannot do, so we have to borrow once again, make the 2 a 1. Bring the 10 over. We have 14 minus 8, 6. We have 1 take away 4, which we cannot do again, so we have to borrow once again, make the 8 a 7. We're going to bring that 10 over, and so we have 11 take away 4, 7, and 7 take away 4, 3. So the question was, how many visitors went to the park in October? So 376,225 visitors. Next problem. A college baseball team had 3 games in April. Game 1 had an attendance of 14,753. Game 2 had attendance of 20,320 people. And Game 3 had attendance of 14,505 people. We want to write the games in order from the least attendance to the greatest. So that's keywords here. Least to greatest. Use pictures, words, or numbers to show how you know. So what is the smallest number? Well, if I even look at in the thousands period, I can see a 14,000, a 20,000, and a 14. I know that 14,000 is less than 20,000. So now, to find the smallest 14,000 number, I look at the rest of the number. I see 753 compared to 505. I know that 505 is less than 753. So I know this number has to be the smallest number out of all 3. That's 14,505. And then the next smallest number after 14,000 would still be the number with 14,000 because 20,000 is much bigger. So we have 14,753. That would come next. And the largest number is going to be the 20,320. And last problem on our review. It says Caden made a 4-digit number. So when you see something like asking you to make a number with so many digits, always draw your digit blanks. That's the easiest way to figure this out. So if it's a 4-digit number, I'm going to draw 4 blanks, 1 for each digit. Then I'm going to fill in the information they give me, which is a 5 in the thousands place, and I know that because I know this is ones, tens, hundreds, thousands. A 5 in the ones place, this is ones, so I'm going to put a 5 there. A 6 in the tens place, so I know this is ones, tens, so this is a 6. And a 4 in the hundreds place, so I know this is ones, tens, hundreds, so that is a 4. And my number is 5,465. And that's all. I hope that you are going to use what I went over today and be able to apply this on your test on Friday. And I'm really excited to see the results and see how you do. It is an all multiple choice test. You will need scratch paper to do your borrowing and all of your work, and then you will choose the correct answer once you've done your scratch work on your own paper. Thanks for listening.